They put need transversal. Right? So these angles have to be connected by a transversal. And if I'm trying to prove A and B are parallel, that transversal can't be A or B. So what can I eliminate because I need a transversal? Are these two connected? It can't be. Yeah, it can't be A because I can't get from 120 to 120 on the lines without making a turn. Same thing here. I can't get straight from the 120 to 60, so it can't be those. Here, A, I'm trying to prove parallel, so it can't be the transversal. It can't be D. These prove C and D are parallel. C is parallel to D. So this is the big distractor. If you're going to get an answer wrong, it's probably going to be D. But then here, I've got 120 and 60 connecting A and B. So this is A is parallel to B. That's going to be my right answer. On this one, the most common wrong answer is C. In this construction, we start with line L, and then we put our compass on P, and we make these two little tick marks. So P is not on the original line. And then you've drawn in this line. So we have a perpendicular line is what we've made from a point not on the original line. So that point P is not on the original line. The original line is purple, is the horizontal line. And that's the tricky one. Almost everybody got D, and those who didn't get D frequently got C, so I'm super happy with that. Number 3, all of you fell into my trap, which happens a lot. Everybody that I looked at chose QT. Why'd you choose QT? I know why you did. I see a 65 and a 65 and a 45 and a 45. It looks easy, right? What's the missing angle? Did anybody calculate the missing angle? If I do 180 minus 65 minus 45, what do I get? 180 minus 65 minus 45. 180 minus 110. What do you get when you do that?
70.
70, absolutely. So we can put our 70 in here. If I look to the opposite side, is the 45 the small angle, the medium angle, or the big angle?
Small.
Small. So that means the 10 is the what side? Is it also the small side? What's the 10 over here? Is it the small, the medium, or the large?
Large.
Large. So even though it is so tempting, and honestly, I do this too, it's 65 and 45, 65 and 45, they match. That means angle, angle. That means they must be similar, right? The problem is that 10. So that 10 is there for a reason. It's opposite the 45. So that's the small side in Q, and it's the large side in T. Those triangles cannot be congruent. So we've got to find the missing angle in the other ones. If I know 45 and 70, this one has to be 65. And I know 45 and 60, this one has to be 75. So 75 does not appear in any of the other triangles. It can't be R. So I can eliminate that right off the bat. So then I go and I look at where this 10 is. And the 10 is across from the 45. That's the small and the small. So instead of QT, what's the best answer? Which two triangles have the 10 as the smallest side? Q and S. This guy right here is the best wrong answer, and it stinks, but that's kind of the way it is. You got to look at all of those things. And if you think it's too easy, sometimes the questions really are easy, but sometimes you got to go, I wonder why they gave me that 10, right? You got to be a little suspicious. Number 4 looked good. This is kind of, I don't know. I've got a small triangle, a medium triangle, and a large triangle, right? And I know that that side and that side are 1 and 2. So I'm going to make a fraction 1 over 2 with that pink triangle. 1 over 2, right? That's a short leg over the medium leg, right? And then I'm going to come over to my next triangle and do short over medium again. So that's going to be 2 over 3. And then I'm going to go to my next triangle, let's do it in green, and I'm going to do short over medium. And that's 3 over 6. 3 over 6. Which two fractions are exactly the same?
2 over 3 and 3 over 6.
2 over 3 and 3 over 6. Are those exactly the same? What is 3 over 6 reduced to?
If we 2, there. 1, no. Oh wait, no, I meant 3 over 6. 1, 2.
It would, absolutely. So 3 over 6 reduces to 1 over 2. Those are exactly the same, right? So those are my two triangles, the pink one and the green one. Which statement shows those? Which answer choices show the small triangle, the CBD triangle, and the big triangle, the ABE triangle? I see CBD and CBD, and then ABE and ABE. What's different about these two choices? It's one of those two choices, because I have CBD, CBD, and ABE or EBA. How do I decide between those two? Clean that up a little bit. If I start at the C, and then I go to the right angle, and then I go to the D, I've gone the short side and then the long side, right? That's this, CBD, short to right angle to long. That means I need to do it this way here, ABE. I need to start and go the short side to the right angle and then to the E. Choice C is better than choice D because of the order of those 3 letters. The devil is in the details sometimes. So this is a stamina question. First thing you got to do is figure out which ones go together, right? And 1/2 and 3/6 are the same fraction, but then they make it even harder and you got to choose the right order, right? It's just kind of stinky. The next 3 questions are about the unit that we're doing right now. So this is test review time. What do we know about a rhombus? They have all 4 sides that are exactly the same. The diagonals bisect each other, and they're perpendicular. And these angles are also bisected. So if this guy is 36, then that also has to be 36, which means I can do the alternate interior angles, and this is 36, and this is 36. If you don't have those things marked on your pear deck, I'd like for you to mark them right now. Mark that angle E right there as a right angle. Mark all the sides that are the same. Mark that the diagonals bisect. And mark that all of these angles at D and angles at B are all 36. I want you to mark all of those. I just realized for those that came in, I haven't given you the pear deck. It is in the folder, but it's kind of hard to find. So let me put it in the chat. I'm sorry about that, guys. So if we know that all these angles at the outside are 36, and we know the interior angle is a right angle, how can we find DAE? DAE, we want this angle right here. So basically, I've got a 36 and a right angle, and I want to know X. How do I find that? Don't everybody talk at once. What do all the angles in every triangle have to add up to?
180.
180. So if I do 180 minus 90 minus 36, what do I get? Many of you got it. 54? Question mark? So remember, in a rhombus, those angles are congruent. All the angles have been bisected by the diagonals. And I kind of messed up teaching that on Friday. So that's why I'm kind of trying to make a big point of it now. Okay? We ready to go on to slide 6? I need your feedback. I can, yeah. Maybe. My computer will go. So slide 4, step 1 was to make the ratios. Oops, I need a pen. Step 1 was to make the ratios. Step 2 was to compare the ratios to see which ones matched. And then step 3 was to make sure that the letters were in the right order. Any other questions? We ready to go look at slide 6? Okay. How do I approach slide 6? What do I know about polygons and all of their interior angles? What was that formula that we did for interior angles? It had a 2 and some parentheses. Absolutely. Interior angles are going to be n minus 2 times 180. What's the n in this case? 6. 6 minus 2, get that number, and then multiply it by 180. How many total angle degrees should be in this shape? 720. And then what's my next step? Absolutely. So I've got a 90-degree angle. I have a 150, and a 90. So if I do angle Z, which is 90, plus angle Y, which is 150, plus angle X, which is 150, plus angle W, which is 90. It should be a 150, by the way, not a 105. Sometimes my brain puts things backwards. If I add all of those up, I should get 480. And then I subtract those from my total, and I get 240. Is that correct? Did I do that right?
Yeah. Yeah.
And then what? So is 240 my answer?
No.
What do I have to do?
Divide it by 2.
Why do you divide it by 2?
Because there's 2 different angles.
Aha, so the U and the Y are sharing that 240, right? So I've got to divide by 2. And when you divide by 2, you get 120. Definitely going to be questions like that on the test. Okay, so you want to make sure you grab that information. So if you need it, you can go back and look at it. What about question 7? How do I attack that? It's going to be very similar. Do I want an interior angle or an exterior angle?
Exterior.
Exterior, so I'm definitely looking for exterior. What else can I do? How would you attack this? And these two things are the same.
If all of the things are the same, you would have like one angle would be the S, 108.
So this interior is 108 because you do 5 minus 2 times 180 to get 540, and then divide by 5, which gives me 108 for the interior. Perfect. And then what do you know?
That you should subtract 180 and 108 and you get 72.
Absolutely. So that's a straight line. Those three angles make a linear pair, or a linear trio in this case. So we can do 180 minus 108, which gives us 72. And then what do you have to do to the 72? You do have to divide it because I've got two of those x's that are sharing that 72 degrees. You've got to divide it by 2. And 72 divided by 2 is 36. Questions on those? No? Okay. So I've got some choices for you. I have a bingo game that we could play. I can open up this pear deck and basically we go through and you put like a red dot on whatever shape this is describing, and it'll kind of give us a review of all of these shapes. If you think this will be worthwhile, we can do this, or we can not, and we can go do the learning targets. So what would you guys rather do? There we go. So what formula is used to find the total interior angle measure of a polygon? We just did that a bunch of times. There are 7 learning targets for sure. And we're on number 1. So what formula do I use for total interior angle measure? It has that minus 2 in it.
Over size times 2.
Yeah, and minus 2 times 180. That's all you need to type into that one. The diagonals in the next question are a little crazy because unless you looked at the digital notebook, you wouldn't know this because I didn't really talk about it. If I have a 4-sided shape, I can divide that going from one angle into 2 triangles. This triangle has 180 degrees and this triangle has 180 degrees. That's how we get the n minus 2 times 180 because the number of sides minus 2 give us the number of triangles. It works for a pentagon too. If I start at one corner, I can divide this into 3 triangles. So that's 180 degrees, that's 180 degrees, that's 180 degrees. So if I do n minus 2 times 180, that's 3 triangles times 180 degrees in each triangle gives me 540. This is kind of the proof, the idea of these diagonals. This is the proof on how we get the interior angle measure. It works for a hexagon too. If I draw a hexagon and I start at one corner, that's the trick. I can divide that into 4. 1, 2, 3, 4 triangles. So that's 6 minus 2 times 180. That's using the number of sides or the number of triangles times 180. Gives me my total interior angle measure. So whatever that makes sense to you, that's how you're going to answer question number 2. I'm giving you a minute so you can type in whatever you want to type in there. This learning target won't give you any answer or any feedback until I grade those two. You need to type something in. So let's look at question number 3. How, given the formula n minus 2 times 180, how would I go about finding the sum of the interior angles of a hexagon? So I'm going to go back up to number 2. The total or the sum of the interior angles of any polygon is n minus 2 times 180. So what do I do in question 3 when it's asking me the sum of the interior angle measures?
6 minus 180.
6 minus 2 times 180. Boom. And that works for every single polygon as long as it's regular. So what would I do for the pentagon? I want the interior angle measure, that's X, and then the exterior angle, that's Y. So how do I find interior? Same way? How many sides in a pentagon? 5. So my n is 5. 5 minus 2 times 180. And then I have to divide by the number of angles because there's 6 of them, right? So n minus 2 times 180 gives me the total. And if I want each, I need to divide it by n again. So what'd you get?
108.
108 for sure. And then the exterior angle, because we could find that first too. Exterior angle, always start with 360. So the exterior angles go all the way around the outside. Remember, a circle is 360. So 360 divided by n, that's going to give me each exterior angle. So this guy is going to be the answer to 360 divided by 5. So if I know the pink one is 108, the blue one is 72. The other way to find that is I know they're supplementary. They add up to 180 degrees. Questions on that learning target? Hopefully that one's pretty straightforward.
Yes,
Oops. Yeah. What am I scrolling up to?
number 3.
So it's just n minus 2 times 180, even though I just realized I can't spell interior correctly. There's an extra E in it. I even proofread these the other day.
I have a question.
Mm-hmm.
Go back and find the 6 minus 2 over the 1.
Yeah, so here to find the total, right? So you're finding the sum here. You want to find the sum, so you don't want to divide those. If you wanted each interior angle, then you would divide it. But you want the sum, you want all of these angles added up.
Thank you.
Yep, you're welcome. So it's definitely important to read the question carefully and answer the right question. Because on a lot of these, you'll have both the individual angle and the sum of the angles as answer choices. So you have to know which one to choose. That was a good question. Any other questions before I go to the next learning target? I have to stop sharing before I do that. Okay. Let's go look at the next one. Come on, little computer. I feel like it's an old car. I have to talk to it. It's okay. All right, so learning target 2 looks like it's interior and exterior angles of polygons. So it's still going to be practicing that n minus 2 times 180. For the interior, and then exterior is going to be 360 divided by the number of sides. All right. It says regular pentagon ABCD is formed by joining the midpoints of the sides of regular pentagon PQRST. I feel like there should be a picture there. Ah, there's the picture. What is the measure of PAB? So if I go from P to A to B, P to A to B, I'm talking about this angle right here. That's the one I want to know. So talk me through that. How would I think about that? If I can make that bigger. What can you calculate? What do you know?
Side.
What side?
Side, like in photo.
I know there's 5 sides, right? Because they're pentagons. 1, 2, 3, 4, 5. Can I calculate any of the angles? Which angles can I calculate?
Or if they're all then they could be 108.
They would be 108, yeah. So they're all 108, right? A, B, C, D, E, and P, Q, R, S, T. All of those are 108. So how does that help me? What if I just draw this blue part that I have highlighted over here? So I draw a straight line, that's PT. I know straight lines are 180 degrees. And then I draw BAE. So this is BAE. And Victoria just told me that's 108 because it's one interior angle of a pentagon. And I want to know this angle. How can I find that? I know that these are the same because everything's symmetrical here. What do those 3 angles add up to be? If they're a straight line. If PT is a straight line because it's the side of a pentagon, what should those 3 angles add up to be? Anybody?
Maybe 360.
If I add up all of the angles, it would be 360. Absolutely. We can start there. So all 4 of those angles, the X, the 108, and the 180, they're going to add up to 360. And what do I know? What angles do I already know that I can subtract out? Do I know the 180?
Yes.
So if I have a whole pizza and my son comes through and eats half of it, 180 degrees are gone, right? And then my daughter comes in and she eats this piece, this 108 piece, right? How many degrees are left for my husband and I? 360 minus 180 minus 108 is what?
No.
How much? Minus 108. We got to make sure our numbers stay in the right order. So 360 minus 180. My son comes in and eats half. So that's 108, 180 left. Then Hannah, my daughter, comes in and she eats 108.
Then 72.
So then 72. So my husband and I split the 72. How much do each of us get? What's 72 divided by 2?
36.
36. So if you think about it, when you're doing these kind of problems, figure out what your total is, subtract out the pieces that you know, and then divide it among the pieces that are left, as long as they're congruent. This is a tough problem to think through. If you think through it one step at a time and just write down everything you know, you're going to be successful. Okay? So we know angle A was 108. We know the two X pieces are the same. We know the whole thing around is 360. We also could have just done this half. So those three angles add up to 180. If we did the 180, I have half a pizza left over from last night. Minus 108 gives me the 72, and then divided by 2 still gives me 36. That's definitely a tough question. What about this one? What am I looking for? An interior angle or an exterior angle? JKL. Exterior, absolutely. And I have this reflexive side right here. The trick to these is to extend out that reflexive side. So I've got an exterior angle of my, I don't know what this is, 1, 2, 3, 4, 5, 6, 7, 8, 9 of my 9-sided shape, my nonagon. And then I've got an exterior angle of my triangle. So if I'm looking for exterior angles, what do I need to remember? What formula? Exterior angle. Think about a big circle. How many degrees in a circle? 360, absolutely. So for my nonagon, I can do 360 divided by how many sides in a nonagon?
9.
9. What's 360 divided by 9, ladies and gentlemen? 40. So that little exterior piece that's orange, that's kind of on the top, is going to be 40 degrees. So now I got to find the exterior angle of that triangle. So that's going to be 360 divided by what? How many sides in a triangle? What's my N for a triangle?
3.
3. What's 360 divided by 3?
120.
120. So if the orange piece next to the nonagon is 40 and the pink piece next to the triangle is 120, what's the total angle from J to K to L? What would you do with those two pieces?
Would you add the 360 divided by 9?
I would add those two things. So 40 plus 120 is what?
160.
Absolutely. So for questions like this, where you have two shapes jammed up against each other, and you're looking for the total exterior angle, find the exterior of one and the exterior of the other, and then add them up. The part plus the part equals the total. How do I find interior or central angles in question 3? How many degrees should all of those pieces of pizza add up to be? Central 360, absolutely. They all come together in the middle of the pizza to make a circle. So what do I have to do with that 360 if I've got 8 slices?
Divided by 8.
Divided by 8. What's 360 divided by 8?
45. 45.
45, absolutely. Central angles, the ones inside a shape that all come together to make a circle, are always going to equal 360. So if they're all exactly the same, 360 divided by n. Central angles and exterior angles, you can find the exact same way. So question number 4, a graphic artist used the polygon below as a logo design. What is the closest measure of each interior angle of the polygon? How do I find interior angles again?
And
And
minus
minus 2 times 180.
We have everybody's saying it. Great. So what do I do? What's the n?
7.
7, absolutely. 1, 2, 3, 4, 5, 6, 7. So it is 7 minus 2 times 180. This is going to be our decimal, I think. So it says closest. You're going to have to round.
Are we looking for the total amount or just 7 minus?
That's a good question. So this one says each. So when you do this formula, you find all of them. What do I have to divide it by in order to find each?
Divide it by 7.
You do divide it by 7, absolutely. In stereo, that's what I was trying to say earlier, and it just got fumbled coming out of my mouth. So 7 minus 2 times 180 divided by 7 gives me what?
It would be 1.
128 something.
It is 128 something. So what's the closest measure?
129.
129.
Fantastic. All right, last 2 questions are about windmills. So we've got a windmill in Williamsburg that has 4 blades that form a regular quadrilateral, which means all of those blades are exactly the same length. What is the central angle? So where do I find the central angle on a windmill? Is that inside at the perimeter? Is it outside the perimeter? Or is it the very heart of the shape where all the blades come together? Central.
Is that where all the blades come together?
It is where all the blades come together. So what we're looking for is that central angle right there. So what math would we have to do to calculate that?
Would do the number of angles. Well, 36 divided by the number of sides.
Absolutely. 360 divided by the number of sides, which in this case is 4. So what's each of those central angles going to measure?
I
90 degrees. Absolutely. All of those are 90 degrees. Those are like the diagonals of a square that are all exactly the same. What about these new modern windmills that Dominion Power is going to build off the eastern shore, off the coast, way out about 5 miles out from the ocean front? How are these modern windmills different?
Would it be 3 sides instead of 4 sides?
Absolutely. So this is a pizza cut into 3 sections. So we still take our 360 for a full circle, but these are more modern. They're huge. Those blades are like, I don't even know, 58 feet long. They stand about 150 feet tall, 200 feet tall. They're like the size of a 15 or a 20-story building. So what's my answer there? What's the central angle of those giant windmills?
120.
120. Does anybody need me to go back to any of them?
Yes, what's the
Number.
was limit 3 to 45?
I know I heard somebody say number 1. Yes, 360 divided by 8 for number 3.
Wait, sorry, I did not do this last one.
So the central angle of the 3-blade windmill, how would I find the central angle of the 3-blade windmill?
You divide it by 360.
360 divided by 3. Central angle is always 360 divided by the number of pieces, or the number of sides, or the number of angles, however you want to look at it.
So number 1 is 36.
Yep.
Thank you.
You're welcome. So we are almost out of time.